In this video, we're going to look at a triple science question on momentum. Just note that for part B, you might not have seen this equation written in terms of impulse, so I've put it on there for you. Pause the video now and trial parts of the question. So in part A, it asks for momentum. Momentum equals mass times velocity. So this is really quite an easy question. If we were to write it in symbols, it is P, which is momentum, equals mass times velocity. So that's going to be 6,000 times by 5, which is 30,000. And then we need the unit. So the unit is the unit of mass, which is kilogram, times the unit for velocity, which is meters per second. A slightly odd unit. It's hard to know exactly what that means by looking at it, but we just literally use the things in the formula to work it out. Part I. BI says calculate the impulse applied to truck B. Well, impulse is force times time. We haven't really been given anything about force or time yet, so that's not helpful. But we can also use the fact that the impulse is equal to change in momentum. So after the collision, truck B has a momentum of this. Before the collision, what is its momentum? Well, momentum is mass times velocity, and truck B is stationary. So before the collision, it's 0. So the change in momentum, this triangle is delta. It means change is 27,000 minus 0, which is obviously 27,000 kilogram. Units for impulse, force times time, which is Newton seconds. The truck's in contact for 0.6 seconds. Calculate the average force on truck B. So we know what the impulse is, and we know that impulse is force times time, because I've told you. So force is impulse divided by time, which is 27,000, divided by 0.6, which is 45,000 newtons. Calculate the final speed of truck A. Well, there's two ways to do this. We could use this relationship here, or my preferred method is to use the fact that momentum is always conserved. So if we look at the total momentum before, that's going to equal the total momentum after. The total momentum before is 30,000. Truck B has 0 momentum. The momentum after is 27,000, because it tells us here for truck B, plus the momentum of A. So that's really easy to see. The momentum of A is 3,000. So therefore, momentum of A is mass times velocity, which is 3,000. We know that the mass is 6,000. So we can write 6,000 times velocity equals 3,000. And then it's really easy to see that V is 0.5 meters per second. It doesn't ask us for velocity, so we don't need to give a direction. If it did ask us for velocity, then we would need to use the fact that they bounce off each other. So we know that after the collision, truck A will be going in the opposite direction. So we'd probably write a minus sign there. But speed is a scalar, so we don't need to do that here.